Hey, welcome. So, have you ever had this awesome idea for an electronic gadget, but then you just got stuck, not even knowing where to begin? Well, you're in exactly the right place. Today, we're going to pull back the curtain on one of the most essential tools for anyone getting into electronics, the solderless breadboard. All right, let's dive in and see how this little block of plastic can seriously bring your ideas to life. So, here's the game plan. We're going to start with the why, the big problem that breadboards were invented to solve. Then, of course, we'll meet the solution itself, take it apart to see how it works, and walk through how to actually use it. We'll also cover a few common mistakes to avoid, and then wrap up with why this simple tool is, believe it or not, more important now than ever. Okay, first up, why do we even need these things? Well, it all boils down to this one really frustrating problem that every single person faces when they try to build their first circuit. You know the feeling, right? You've got this brilliant idea sketched out, all your parts are sitting right there on your desk, but there's this huge gap between the drawing and a thing that actually, works. How do you connect all those little legs and wires without making a total mess that you can't undo? And this, right here, really gets to the heart of it. For a long time, your main option was soldering. And look, soldering is great for a final product, but for testing an idea, it's permanent. If you mess up, it is a huge pain to fix, and you're always running the risk of frying your expensive components with too much heat. The breadboard, on the other hand, it's the complete opposite. It's temporary, you can use it over and over, and it's totally safe for your parts. It's all about freedom and flexibility. And this brings us to the hero of our story, the simple, elegant, solderless solution to that whole prototyping headache. So what is a breadboard, really? At its core, it's just a base for building circuits. But the magic words are right there on the screen, reusable and without soldering. That means you can build a circuit, test it, find a bug, tear it down, and rebuild it in minutes. You can experiment as much as you want until you get it perfect. And get this, the name is totally literal. Back in the 1920s, radio hobbyists would literally grab a wooden bread cutting board from the kitchen and nail their components to it. But the real game changer, the one that led to the boards we use today, came in 1971. A guy named Ronald Portugal patented a design with that perfect 0.1-inch spacing between the holes, which just so happened to be the exact same spacing as the pins on integrated circuit chips. And just like that, the modern breadboard was born. All right, so we know what it is and where it came from. Now it's time to pop the hood and see what's going on inside. Because once you understand the layout, using one becomes second nature. From the outside, it looks kind of boring, right? Just a piece of plastic with a ton of little holes. But inside, it's like a hidden city grid of tiny metal pathways. And those pathways are arranged in a really, really clever way to make your life easier. That grid is basically divided into two main zones. You've got the bus strips running down the sides. Think of these as the power highways for your circuit. They're connected vertically all the way down the board. Usually you'll see a red line for your positive voltage and a blue or black line for your ground. Then, in the middle, you have the terminal strips. This is where all the action happens. These are short little rows that are connected horizontally, and this is where you'll plug in all your chips, resistors, and LEDs. Okay, now for the really cool part, the X-ray view. Imagine we peel back that white plastic. What you'd see is that under every single hole, there's a tiny metal spring clip. In the terminal strips, you can see that any 5 holes in a single horizontal row are all being grabbed by the same metal clip. That's what connects them. The bus strips on the side, same idea, but their clips run vertically down the entire length of the board. And that big ditch in the middle, that's the center notch. It's a dead zone, and it's designed so you can place a chip right over it without its 2 rows of pins touching each other. Pretty smart, huh? Okay, theory is great, but let's get our hands dirty. How do you actually put a circuit together on one of these things? It's actually a really logical process. First, you gently press your main component like a chip so it straddles that center notch. Easy. Step 2, you run jumper wires from those power bus strips, the red and the blue ones, over to the pins on your chip that need power and ground. Now for the magic. Let's say a resistor needs to connect to pin 3 of your chip. You just plug one leg of the resistor into any other hole in that same horizontal row as pin 3. That's it. The metal clip inside does the work for you. Finally, you just use a few more wires to connect everything else up. And hey, a couple of pro tips about those wires. You really want to use 22-gauge solid core wire. It fits perfectly in the holes. When you strip the insulation off the ends, aim for about 5 to 8 millimeters. Too short, and you'll get a flaky, unreliable connection. Too long, and you're just asking for a stray bit of metal to touch something it shouldn't and cause a short. And please, do yourself a huge favor. Color code your wires, red for power, black for ground. It will make your life 1,000 times easier when you're trying to figure out why your circuit isn't working. Now, as much as I love breadboards, they are not perfect. And it is just as important to know what they can't do as it is to know what they're good for. And look, this isn't about being negative. This is about being a smart builder. When you understand the limits of your tools, that's when you can really start doing amazing things with them. So the thing to remember is that breadboards introduce some electrical quirks. Those long metal strips inside can act like tiny antennas, which creates something called parasitic capacitance. It's not a big deal for most circuits, but it can mess with really fast, high-frequency signals. Also, the connections aren't perfect. They add a little bit of resistance. And in a really complex circuit, it's possible for a wire to get a little loose. Oh, and they're not made for those super tiny modern surface mount parts you see everywhere these days. Which brings us to the big one. As a general rule of thumb, breadboards really don't like signals that are switching faster than about 10 megahertz. So what does that mean? It means they are fantastic for audio projects, most microcontroller circuits, and basic logic. But they are not the right tool for things like high-speed radio or fast digital communication. So if they have these limits, why is pretty much every electronics bench in the world guaranteed to have a breadboard on it? Well, it's because in the modern age, they've found their perfect partner in crime. In today's world of super powerful, super cheap computers on a chip, like an Arduino or a Raspberry Pi, the breadboard has become the absolute best way to build and test all the stuff that connects to those little brains. I mean, just think about it. You can slap together a sensor circuit, test out an LED, or hook up a motor driver in seconds. It lets you write your code, your firmware, while you're interacting with real physical hardware, not just guessing in a simulator. It literally closes the gap between having an idea and having a working prototype from days of work down to just a few minutes. It's a total game changer. At the end of the day, that's what the breadboard is all about. It makes electronics approachable, it makes experimenting easy, and it makes it fun. It takes the power of invention and puts it right at your fingertips, letting you turn a complicated idea into something real you can hold. So the only question left is, what are you going to build?